All right, here we go. Whammy day 5. It says solve each system of equations without graphing. So we talked about two different ways to solve systems of equations without graphing. And those two ways, if we remember, are the first way is substitution and elimination. All right, so I'm going to solve through both ways to work these out, and you can just choose which one makes more sense to you or which one you understand better, okay? So I'm going to start with substitution. So let's look at A. Let me kind of mark this off. Let's start with A. So we have our system. We have 2v plus 6w equals negative 36, and then we have 5v plus 2w equals 1. All right, so the main thing you have to know for substitution, is that you have to solve for a variable. All right, so you can really choose whichever one you want to solve for. Okay, so I'm looking at this and I think I want to solve for, I'm going to choose this equation. This equation, I'm going to solve it for W. Okay, all right. Oh my gosh, get it together. All right, so I'm going to solve it for W. So I'm going to get this 5v and I'm going to move it to the other side. Those cancel out and I have 2w equals 1 minus 5v. And then still got to get that w by itself, so I have to divide it by 2. Divide it by 2. Those 2's cancel out, and w equals 1 divided by 2 is 1/2, minus negative 5 divided by a positive 2 is going to be 2.5 v. Okay, so now that I have solved this for this second equation for w, I can now substitute it into my other equations. Okay, so that's why it has the name substitution. You're substituting it in. Okay, so I'm going to go back to my, since we used this equation, I'm going to use this one now to solve. Okay, so I now have 2v plus 6, and I'm going to substitute because I have a w here, and I know that w equals 1/2 minus 2.5v. So everywhere I see a w, I can just substitute it in for that. And that equals negative 36. Okay, so now I have an equation that only has one variable in it. We can't solve these two up here because it has two different variables. You can't solve an equation that has more than one variable in it. Okay, so now we're going to take that and we are going to solve it. Okay, so I'm going to start by taking this number 6 and I have to distribute it to everything on the inside. Sorry, my coach is trying to get in the video. Coach, come on, say hi to everyone real quick. Okay, say hi, Coach. Okay, here, maybe you can just sit in my lap, bud. Got a job to do. Oh, okay, so I'm going to distribute that 6. All right, so now I'm left with 2v. We can't forget about that 2v to bring it down. So I have 6 times 1/2. 1/2 of 6 is a 3. And then I have the 6 times a negative 2.5. So 6 times 2 is 12. 6 times 0.5 is 3. So 12 plus 3 would give me a negative 15 b. Okay, I'm going to double check that in my calculator because I haven't done math a lot during this quarantine. All right, it's 15. Okay, and all of that equals negative 36. Okay, so now before I move on, I need to combine my like terms. Okay, and what I mean by that are the terms that have either the same variable or they're both constants, meaning they're numbers by themselves. Okay, so I see that I have this 2v and I have a negative 15v. So I'm going to combine those two together. Okay, so positive 2 minus 15, that's going to give me a negative 13v plus 3 equals a negative 36. Okay, so now I have to move this positive 3 over here because those are both constants. So I'm going to subtract 3, those cancel out, and I'm left with negative 34v equals negative 36 minus 3 is a negative 39. There are a lot of steps to the substitution, so don't get lost in all of the steps. Okay, then I'm almost done solving for v, so I just have to divide both sides by negative 13. Divide by negative 13. Those cancel out, and v equals negative 39 divided by negative 13 is 3. Okay, so now I've solved for one of my variables from my original equation. I have to go back and solve for my other variable. Coach, get down. Okay, so I'm just going to go up here where I have what w equals, and I'm just going to plug in 3 for v and see what I get. So I'm going to rewrite my equation. I have w equals 1/2 minus 2.5 times 3 because v equals 3. So again, I'm going to substitute it in. Okay, so w equals, I'm going to start by order of operations. I have a negative 2.5 times 3. And that gives me a negative 7.5. So I have 1/2 minus 7.5. So I get, nope. Gives me a negative 7. So w equals negative 7. Okay. So if we think all the way back to when we did systems of equations back in the first 9 weeks, when we're solving for a system of equations, we're wanting to know when those two equations cross on the graph. So these points are going to, okay, so these points are going to intersect at 3, negative 7 on the graph. And you can always go and double check your answer. On your favorite website, Desmos. Okay, so remember you can't do anything other than x and y, so I have 2x plus 6y equals negative 36, and then my other equation was 5x plus 2w equals 1. Okay, so if I were to zoom, 10 time out, what did I do wrong? Oh, I did w. Okay, so I'm seeing where those 2 points, where'd I go? Right here. At positive 3 and negative 7, which is exactly what we said. Okay, so it's just that point where they intersect, and that's how you solve it by substitution. So let's do the next one and solve it by substitution as well, just so you can see all of those steps again, and maybe you'll kind of start being able to pick up on what those next steps are. Okay, so let's kind of divide up that section. Okay, so I'm looking at B now, so I'm just going to come down here and I'm going to rewrite B. So our system of equations is 6t minus 9u equals 10, 2t plus 3u equals 4. That's a u. Just don't want it to look like a weird letter. Okay, so here we go. Again, we're going to solve this by substitution. So we got to remember what our first step is when we're solving for substitution. We have to make sure we solve for a variable, okay? So let's go and do that. And again, it doesn't really matter which one you choose. So I'm just going to use the second equation again, just like we did the last time, and I'm going to solve it for you. So step one, solve for a variable. So again, I'm not being specific on which variable you have to solve for. It's really just whatever one you want to solve for. Okay, so I have 2t plus 3u equals 4. So I'm going to solve for this. Subtract 2t, subtract 2t. I have 3u equals 4 minus 2t. Again, we can't combine those terms because they are unlike. Then I divide by 3, divide by 3. And I have v equals 4 divided by 3 is 4/3. A negative 2 divided by a positive 3 is just going to be negative 2/3. Okay, so there is my first step completed. All right, now we want to take that, and in step 2, we want to plug into other equation. All right, and remember we talked a lot about this when we learned substitution. Anytime you see that plug into, that literally means to substitute, okay? So again, that's where it gets its name. All right, so you have to plug it into the other equation, because if you just plugged it back into the equation you solved for, then you can't do that. So I'm going to go back, and the first equation was 6t minus 9u equals 10. Okay, so I have, oh wait, that's supposed to be a u, not a v. See, look at me. I need to make sure I'm paying attention. All right, so 6t minus 9, and it's supposed to be a u equals 10. Okay, but we know what u equals now. We know it equals all of this up here. So we're just going to substitute it in for that variable. Okay, so I'm going to rewrite it. I have 6t minus 9, and everywhere I see a u, I'm going to replace it with 4/3 minus negative 2/3 t equals 10. And just like last time, now we have an equation that only has one variable that we're working with, and that's why we do substitution, because you can't solve an equation that has two different variables in it. Okay, so let's keep going. So first step we're going to do is we're going to take this negative 9, and we have to distribute it through to everything in the parentheses. Okay, so got to remember to bring down that 6t. So we have negative 9 times 4/3. So I'm just going to plug that in my calculator. Negative 9 times 4/3 is negative 12. Okay, so that's going to be a negative 12. And then I have a negative 9 times a negative 2/3 t. Okay, so again, negative 9 times negative 2/3. Okay, since it's a negative times a negative, it's going to give me a positive 6t equals 10. Okay, so don't be intimidated by the fractions at first, because look, they came out into whole numbers in the end. Okay, now just like last time, we are going to combine our like terms. So I see that I have a positive 6t, and then I have another positive 6t. Okay, so going back to my orange, so I have 6t plus 6t, that's going to be 12t minus 12 equals 10. Okay, so I'm going to add 12, add 12. So I'll get 12t equals 22 divided by 12 divided by 12, t equals 11/6. Okay, let me make sure I did all of this correctly. Okay, yeah, so you get 11/6, or if you want to change that to a decimal, you get 1.83 repeating, okay? Now we know what t is. Now we can use that and substitute it into the equation from earlier, and we can solve for u. So we know that u equals 4/3 minus 2/3 t. And if we know that if t equals 11/6, we can just take that and plug it in or substitute it. Okay, so I have u equals 4/3 minus 2/3 times 11/6. Now we have to follow order of operations. So I'm going to do multiplication first. I have 2/3 times negative 2/3 times 11/6. Okay, so just to keep it consistent with the fractions, and so we have a more exact answer, I'm going to keep it as a fraction. So I get negative 11/9, and then 4/3 minus 11/9 is 1/9. Or if you wanted to write it as a decimal, you get 0.1 repeating. Okay, so again, if we think back to what we just did in the other one, I know this one's a little weird because it doesn't come out as whole numbers, but it's still that same idea. It's that point. If we were to graph the two equations that we started with, we would have graphed these two equations, then it should intersect at 1.83 repeating and 0.1 repeating, okay? So I went ahead and I graphed it, and we can see the intersection point right here is at the exact same thing that we said, okay? So that is how you solve both of those by substitution. And now I'm going to take you through how to solve them both by elimination. And regardless of how you solve them, you should still come out with that same intersection point. Okay, so let me just write them here. I'll just split this screen over here. Okay, so let me grab my highlighter. I'm going to draw, okay. All right, now we're going to do this by our second way of elimination that we talked about earlier, okay? All right, so when we're solving these with elimination, you are trying to eliminate one of the variables, okay? So that's how this one gets its name. So let's see, we have, you can just see it right there. So we have 2v plus 6w equals negative 36. And we have 5v plus 2w equals 1. Okay, so I want to, maybe let me move me out of the way. Okay, so in order to eliminate a variable, you have to have your variables match up, which in this case, they don't, okay? So your first step is going to be to change them somehow. Let me see if I can make this bigger so we can see what we're doing here. Okay, just kind of ignore this side over here with our substitution notes. So what we're going to have to do is we're going to have to multiply one of these equations by something to where it has a variable that matches up, okay? So I can see that if I were to take this equation right here, and if I were to take both sides of it and multiply it by 3, then I would have 2v plus 6w. That stays the same because we didn't multiply it by anything. Okay, and then this one would say 3 times 5 gives me 15v. Okay, so these variables are still different. Okay, that didn't change. And then I have 3 times 2, which will give me a 6w, which is good. We want those coefficients to match up. And then we have 1 times 3, which is 3. Okay, so the first step is to multiply equations so we can eliminate. Yeah, that looks right. Okay, so now this is our new equation. So just by multiplying it by 3, we know we've just created an equivalent equation. It doesn't change it. If we were to graph it, it would still be the same line. Okay, so now that I know that those are the same variable, I have to try to eliminate them. Okay, so if I have a positive 6 and a positive 6, you can either add them together to eliminate them, or you could subtract them. So if I did 6 plus a positive 6, that would just give me 12. Okay, so that's not going to help me at all. What I want to do is I want to take them and I want to subtract them, because if I said a positive 6 minus a positive 6, they would cancel out or be eliminated. Okay, and that's what I want. Okay, so since I have to subtract, I have to do it to the rest of it to keep it the same. Okay, so I have 2 minus a positive 15. So 2 minus a positive 15 is going to give me a negative 13v. We said those are eliminated, so it's just 0, and that equals negative 36 minus 36 gives me a negative 39. Okay, and so then I just solve for v. So I divide both sides by negative 13. Those cancel, and v equals negative 39 divided by negative 13, and that gives me 3. Okay, v equals 3, and that is exactly what we got earlier when we did it for substitution. So just because we're solving it a different way doesn't mean you should get a different answer. Okay, now that we know what v is, we can just take one of the original equations and solve it for w. So I'm just going to choose this one. It doesn't matter really which one you choose. So I'm going to choose 5v plus 2w equals 1. And I know that v equals 3. So I'm just going to substitute that in. Okay, that same concept. So 5 times 3 plus 2, whoops, that's a weird 2. 2w equals 1. Okay, so that's 15 plus 2w equals 1. Now, again, I'm trying to solve for that w, so I have to get it all on one side. So I subtract 15, subtract 15. Those cancel, and I have 2w equals 1 minus 15 gives me a negative 14. So if I'm still solving for w, I have to divide that by 2, divide that by 2, and w equals negative 7. And again, that is just like what we got earlier. Okay, so that is how you would solve that one, that same exact system of equations by elimination. So depending on which one you think makes more sense to you, just use it that way. Just when it says without graphing, you're going to solve it with one of those two ways. All right, now this last problem we're going to work out with, let's see, with elimination. Okay, so let me get my pens. Let me move me out of the way again. Just keep getting in the way of stuff. All right, Last one. Again, we're going to solve this by elimination. And I got to look back and see what the original equation. Don't want to lose my screen. 6t minus 9u equals 10. And 2t plus 3u is 4. All right, so I know this is all over the place, guys, but please bear with me. I'm trying to make this as simple as possible. All right, so we're going to solve this with elimination. So again, your first step is to multiply an equation so we can eliminate a variable. All right, so again, none of my coefficients are matched up. So I just have to look and see what I would want to multiply it by or divide it by to get one of those coefficients matching up. So let's see here. I see that I could multiply this one by 3. See here? Yeah, so I can multiply this one by 3 because 2 times 3 would give me 6. Okay, so let me change colors so you can see me doing that. Okay, so I'm going to take this equation, I'm going to multiply both sides by 3. So my new equations, that first one is going to stay the same because I'm not multiplying it by anything. Okay, so then that's going to give me 6t plus 9u equals 12. All right, so here is the new equation that I'm working with. So now I see that I have 2 coefficients that match up. So it's really whichever one you want to work with. So I'm going to eliminate my t first, just because that's how I want to do it, not because that's the one you have to do, but that's just the way I'm choosing to do it. So if I want to eliminate that, if I have a 6 and a 6, if I were to add them together, that would give me 12, which wouldn't help me at all. If I want to eliminate them, I need to subtract those from each other so that they are eliminated. So a positive 6t minus 6t would just cause those two to cancel, and that's almost like a 0. All right, then I have a negative 9 minus a positive 9. Okay, so notice how I emphasized those signs with it because that's really important if you want to make sure you get that correct thing. Make sure you get that correct answer. Okay, so I have negative 9 minus a positive 9, which gives me negative, oh my gosh, why do I keep doing that? Gives me a negative 18u. Okay, a lot of people are going to think, oh, a negative 9 and a positive 9, they just eliminate and it's 0. But because you're doing a negative 9 minus a positive 9, it's going to give you negative 18u. So you really need to pay attention to those signs. Okay, and so then you have 10 minus 12, which is going to give you a negative 2. Okay, so then we are going to then divide it. So we have divided by negative 18, divided by negative 18, those cancel, and u equals 1/9, or if you want to write it as a decimal, 0.1 repeating. All right, guys, which again is just like what we had earlier. Okay, so that's good to know. Now, since we know what u is, then we can just take it and substitute it in. Okay, so let's go up here, let's change colors. Okay, so I know that u equals 1/9, so I can just take that and literally plug it into any of the equations. So I'm just going to choose 6t plus 9u equals 12. Okay, so I know that u equals 1/9, so I'm just going to substitute that in. Oh, wow, that looks confusing. Okay. All right, now we just have to simplify it. So I have 6t equals 9 9 times 1/9, which, oh my gosh, what am I even writing, guys? Okay, 9 times 1/9 would be 9/9, or we could just say it's 1 equals 12. I'm going to get rid of that 1. Those cancel. So I have 6t equals 11 divided by 6 divided by 6. T equals 11/6, or just like we said earlier, 1.83 repeating. Okay, and guys, that is again exactly what we got earlier when we solved it by substitution. Okay, so I know this is a longer video. I know there's a lot more steps to these questions, but this is a very important Algebra 1 skill that you've got to learn. And this will probably be something that you see again next week as just like some review, just so that we can keep that fresh and understand it. So really watch through this whole video, see which one makes more sense to you, and because you will see it again soon. Okay? All right, guys. Hope this helps. See ya.